Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA November 2023, Paper 3, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. The first four terms of a linear sequence are 6, 13, 20 and 27. Write down the expression of the nth term. Okay, so when you're looking at sequences, the first thing you really should look at is the difference between each of the terms. And in this case, from 6 to 13, that's add 7, isn't it? And then from 13 to 20, that's also add 7. And 20 to 27, that's also add 7. Not really a surprise, it did tell us it was a linear sequence there. And linear sequences have numbers going up in equal increments like that. And in terms of the nth term, we can have an n in the nth term, and whatever that number there is in that it's going up in for a linear sequence, that's the number that appears in the front. So it's going to have something to do with 7n. But 7n, the sequence 7n, when n is 1, I'm going to get 7, and when n is 2, I'm going to get 14. So you can see, and so on, and 21 and 28. And you can see the sequence that I've got is 1 less than the 7 times table. So to go from 7n to what I've got written there, I'm going to have to take 1 away from each term. Okay, so the sequence is 7n, take away 1. Question 2. Square A is enlarged to square B. Write down the scale factor of the enlargement as a fraction. Okay, so we're actually going from A to B, aren't we? So, you know, it's a mathematical enlargement, but actually, if you look at it, it's being reduced in size, isn't it, rather than enlarged. Okay, so that means it's going to have a fractional scale factor. Now we can find the scale factor of an enlargement by taking two measurements that match. So we've got this 12 here and we've got this 8 here. Okay, and then if we take the size on the image, the second one, and we divide it by the size on the object, which is the first one, that is going to give us the scale factor. So the scale factor of this one is 8 over 12, which, you know, we can cancel that down, can't we? So that's going to be 2/3 then, isn't it? Okay, so 2/3 is the scale factor. Question 3, the length of a line is 8 centimeters to the nearest centimeter. Complete the error interval. Okay, so if it's round into 8 centimeters, if you imagine a ruler and you had 8 centimeters marked on it, and it was and the ruler had centimeters, so the boundaries at either side are going to be 7 and 9, aren't they? So which numbers round to 8? It's going to be the numbers that are halfway between 7 and 8 up to halfway between 8 and 9, then, isn't it? It's the numbers in this range round to 8. You know, if it's slightly smaller than this point there, it's going to round down, and if it's slightly bigger than this point, it's going to round up. So halfway between 7 and 8 is 7.5, and halfway between 8 and 9 is 8.5. So the error interval is going to be 7.5 is less than or equal to the length, which is less than 8.5. Okay, so notice the different signs there. You've got greater than or equal to there, or less than or equal to, depends on which angle you're looking at it, and then a strictly less than simple second, because it can be equal to the lower bound, but it can't be equal to the upper bound. Question 4, at what point does the graph y equals x cubed minus 1 cross the y-axis? Well, the graph y equals x cubed, well, the graph y equals x cubed, you should know what it looks like. If you've got an axis, then the graph y equals x cubed is going to be a line like this. It looks like that as an x cubed. So if you're then going to take 1 away, this is actually a transformation of that curve. It moves it 1 square down, doesn't it? So you'd end up with a curve that looked like this. Okay? And that point there would be minus 1. So where does it cross the y-axis? Well, that coordinate down there is 0, minus 1, isn't it? Question 5. Carly's total annual pay equals her salary plus her bonus. Last year, her salary was £26,000 and she got a bonus of £4,000. This year, her salary is increasing by 6%, but her bonus is decreasing by 9%. So work out the percentage change in her total annual pay. State whether it is an increase or a decrease. Okay. So there's actually quite a bit to do here. Right, so last year she earned the total of her salary plus her bonus. So last year she got a total of £30,000, didn't she? The 26,000 plus the 4,000. Okay. Now this year her salary part, the salary component of her wage, is increasing by 6%. So final, original, multiplier. Let's work out what's going on here then. FOM, stick your thumb on it. I like to use this triangle for my percentages. Now the final amount is the amount that's going to happen after the 6% increase has been applied. The original is, well, it's going to be the starting salary, which is going to be the 26,000, isn't it? That's there. That's going to be 26,000. And the multiplier, well, we've got a 6% increase, but what are we increasing? We start with 100% and we're increasing it by 6%. So that's going to give me 106%, which as a multiplier is 1.06. Okay? So for the salary component, final equals, we'll just stick your thumb on the one you want, which is final, and that tells us what to do with the other two. It's original times multiplier. So final equals original times multiplier, which is going to be the 26,000 she earned last year multiplied by 1.06. Okay, time to reach for the calculator. So 26,000 times 1.06. I made that 27,560. Just going to write that up here as well. So it's all in one place. Now we also need to work out what's happening with her bonus. Her bonus is decreasing by 9%. So I'm going to do another triangle. Final, original, multiplier. Now this time, well, I'm still looking for the final after a decrease of 9%. Now last year it was 4,000, so that's going to be my original. The multiplier, so that's the original there, and the multiplier this time is going to be that 9% decrease then, isn't it? So 100%, because you always start with 100%, minus 9%, because it's a decrease, leaves us with 91%, and 91% as a multiplier is 0.91. So again, final is equal to original times multiplier, the original this time being 4,000, the bonus, and the multiplier being 0.91, the amount we're going to get this year. So 4,000 times 0.91, that comes out to be 3,640. 3,640. So that's going to be the bonus component for this year. Okay, so then the total for this year is going to be those two numbers added together. So the 3,640 plus the 27,560 from the salary that comes out to be 31,200. Okay, so despite the increase on the salary being less than the decrease on the bonus, you know, because the salary was worth more to begin with, it ended up contributing more overall, and her salary has actually gone up by a little bit. Okay, now we're not quite done yet because we need to work out what the percentage change was from last year to this year. So we're going to do another triangle. Final, original, multiplier. This time we know the final and the original. We want the multiplier. The final is the new salary. It's the 31,200. The original is the old salary, 30,000. And the multiplier is the thing we want to find. We want to find the percentage change, don't we? That's the thing we want. So putting our thumb on the thing we want the multiplier. Multiplier is final over original. So multiplier is final divided by original. That's going to be 31,200 divided by 30,000. What's that going to be equal to? 31,200 divided by 30,000. Now that comes out to be 1.04 as a decimal. Now 1.04 as a percentage would be 104%. And that as an increase then means an increase of, well, if you had 100% to start with and you now got 104%, it's an increase of 4%. Okay, and that is our final answer. It's an increase of 4%. Question 6. An exhibition was open for 240 hours and had 29,760 visitors. For 2/5 of the time the exhibition was open, there were 172 visitors per hour. For the remaining time, how many visitors per hour were there? So lots of numbers here to deal with. Let's kind of go through the questions. So for 2/5 of the time the exhibition opened, there were 172 visitors per hour. So we've got two stages, haven't we? We've got the first 2/3, which has one particular rate of visitors per hour, and then we've got a second stage where we need to work out another number for the visitors per hour. So we're going to break it down into stage 1 and stage 2. So for stage 1, it was 2/5 of the time the exhibition was open, and it was open for 240 hours. Okay, so if I work out, so for the stage 1, it was open for how long? It was going to be open for the 240 hours in total times the 2/5, which is the fraction of the total time it was open for. So on my calculator, 240 times 2/5, that comes out to be 96. So this first visitor per hour rate applied for the first 96 hours. So the total number of visitors for the first stage is going to be the 96 hours that it was open, multiplied by the 172 visitors per hour that that came. Okay, so that came from there, that came from there, and then that came from there, and I haven't done the last part there, and times 172, which came from there. Okay, so the number of visitors equals 96 times 172. So 96 times 172, that comes out to be 16,512. Right, and then for stage 2, the second part of the exhibition, now we want to work out the number of visitors per hour. We should be able to work out the total number of visitors that visited in this stage, because we've got the total number of visitors altogether, plus we now know the number of visitors that came in the first part of the exhibition. So if we take one away from the other, we'll know how many came in the second part. So number of visitors. So it's going to be the 29,760 that came altogether, minus the 16,512 that came along in the first session. So taking one away from the other, 29,760 minus the answer. That comes out to be 13,248. So that's equal to 13,248. So then what's the rate of visitors per hour? Well, that's going to be the total number of visitors divided by the total number of hours that they were there. Okay, so how many hours were there now? So we've already accounted for 96 hours, haven't we? So what is 240 minus 96? That's going to be 144 hours. So the second stage is 144 hours long, and we had 13,248 visitors in that time. So if we divide 13,248 by 144, we should get our answer then, shouldn't we? So 13,248 divided by that should give me 92. So we had 92 visitors per hour in the second part of the exhibition. The first two cube numbers are 1 and 8. Show that the third cube number can be written as the sum of three different prime numbers. Well, the third cube number is 27, isn't it? Because it's 3 times 3 times 3. So 3 cubed is 27. So that's going to be the third cube number. Now, is that apparently I can write that as the sum of three different prime numbers. So I need to find some prime numbers first, don't I? So I need to find the prime numbers that are less than 27, I guess, so I can combine them to make 27. So what are the primes? We've got 2, we've got 3, we've got 5, we've got 7, we've got 11, we've got 13, we've got 17, 19, not 21, 23, not 25, and 27 not either. So they're the primes that we've got. So we want to add up to 27. Now it's an odd number, so can't include 2 then, can it? Because an even plus an odd is an even. So it can't have 2 in it. So what can we do? Let's say we add 3 and 5, we get 8. We've got 19 left to find. So that works, isn't it? So 3 and 5 and 19 works. There might be others. I don't know. Can I be bothered to find out? Not really. But if you've got another set of numbers from this set of numbers that adds up to 27, go you. You'll get the marks. Question 8. Circle the largest number. Which is the largest number? Okay, well, they're written in different formats, aren't they? I'm just going to write a few extra digits on some of these so we can easily compare. I think I want to include 4 decimal places showing on each one of these because we've got some numbers with recurring decimals. So the first one would be 3044 and so on. This one I'm just going to write with an extra 0 on the end, so it's a kind of a similar size. This one I'm going to write with 2 extra zeros on the end, so it's a similar size. And this one I'm going to write the extra 4s I need, so it's got 4 digits after the decimal place. And now we can kind of easily compare them. Now they all start with 5.3, so that's so far so much the same. Okay, and then after that we've got this one here which has got a 0 at the front, and then all the others have got 4s. Okay, so they're all the same. So that means that the first one is the smallest. And then, so what we got after that? So then the next digit, well, this one is a 0, but then these two are 4s. So they're the same. So then finally, comparing this last one, look, that one's got a 40 and that one's got 0. So it's going to have to be that last one on the end. It's going to be 5.34 with a dot on the top. Question 9. Use trigonometry to work out the size of angle W. All right, nice straightforward trigonometry question. So what do we know about trigonometry? SOHCAHTOA for right angled triangles. So what I normally do is I write down the mnemonic SOHCAHTOA, and then I work out what sides have been given and and so which ratio that I need to use. Okay, so label up my triangle. Here's the angle down here. Okay, and there's the angle. This side is the longest, so it's got to be the hypotenuse. The 6.7 joins onto the angle I've been given, so that's got to be the adjacent. And this one over here that we don't know anything about and don't want, that's the opposite. Okay? So then you need to choose which is the right ratio to use in this case. Now, I often find it's easiest to think about the one I don't want rather than the two that I do. So I can see I don't want the opposite because I don't know it and I don't want it. So any of the ratios with an O in it, it can just remove. So it must be the cosine that I'm after. That's kind of how I do it. So rather than finding two things, I just find one and get rid of them. So it's the cosine I want. So I'm going to write down the full cosine formula. Cos theta is equal to the adjacent over the hypotenuse. Now when you remember the trigonometric formulas, remember them with the placeholder for the angle. Don't forget about the theta, because lots of students make errors subbing into these because they just write cos equals rather than cos theta and don't know where to stick their angle. So cos theta is equal to adjacent over hypotenuse. Now in this particular case, we haven't got theta, we've got w standing in for the angle. So I'm going to switch to w, cos w, and I'm going to sub in the other two values as well. So the adjacent is 6.7 there, look. 6.7, and the hypotenuse, that's over here, look, that's 8.3. So 6.7 divided by 8.3. And then I want w. I've got cos w is equal to that fraction, but I want w. So what I'm going to have to do is I'm going to have to use the inverse cosine here, aren't I? To get rid of that cos w and just get w, I need to take the inverse cosine of both sides, and that's going to give me cos to the minus 1 of 6.7 over 8.3. Now, I'm going to type that into the calculator. Just make sure your calculator is in degrees mode. It's got a little D on the top of the display, otherwise you'll get the answer wrong. And then I'm going to press the shift key before pressing cos, so I can get cos to the minus 1. And then I'm just going to put it in using the fraction key. So I'm going to put 6.7 on the top, and I'm going to put 8.3 on the bottom, and ask the calculator to give me the answer. I make that 36.17, which I'm going to round off. I'm just going to round off to three significant figures. So that's going to be 36.2. 36.2 what? This is an angle, so it's going to be in degrees. 36.2 degrees. Question 10. Two bags contain only green discs and yellow discs. Bag A contains 1 green disc and 4 yellow discs. Bag B contains 3 green discs and 7 yellow discs. 1 disc is picked at random from each bag. Complete the tree diagram with their correct probabilities. So I've got bag A. I like little visual things. So I'm gonna. I've got 1 green disc and 4 yellow discs. 1, 2, 3, 4 in a bag. There's my little bag, and then I've got bag B, and then I've got, what have I got in there? I've got 3 green discs and 7 yellow discs. What thing is going on in that bag? 3, 4, 5, 6, 7. Okay, it's quite a simple, straightforward question, this one, but you know, I think it's a good idea to visualize things. So there we go, there's my 2 bags. So I'm going to pick one is picked random from each bag. So this is an example of independent probability, because what I pick in bag A cannot in any way influence what I'm going to pick for bag B. You know, if I had to pick something from bag A and then put it in bag B and then pick from bag B, it would be different. But I don't. I'm just picking from bag A and then I'm picking another one from bag B. Now, for bag A, there's 1 green one and 4 yellow ones, meaning that there are 5 discs altogether. So the probability of getting a green is going to be 1 out of 5. Okay? So the probability of not getting a green, in other words, getting a yellow, is going to be 4 out of 5. Okay, so we're done with the bag A. Switching to bag B. Now I've got 3 green, 7 yellow, making 10 altogether. So the probability of picking a green one is the 3 green ones out of the 10 tokens or discs. And so the probability of getting not green or yellow is going to be 7 out of 10. Now this is independent probability, so the probabilities on the second branch down here are going to be the same. Doesn't matter what we do first time, it's still going to be the same probabilities of picking for the second one. Okay, so that's what my completed tree diagram should look like. Now part B says work out the probability that both discs are green. Okay, so both discs are green is going to be this branch I pick green, and then this branch I pick green. So then the probability of green is going to be multiplying every fraction along that route through the tree diagram. So I've got 1/5 here, look. So I'm going to multiply that, and I'm going to multiply that other one, 3/10. So 1/5 times 3/10. What's that going to give me? That's 3/50. Okay, so the probability of green is 3/50. Question 11. Solve these simultaneous equations. I've got 7x plus 2y equals 100, and I've got 3x plus 2y is equal to 48. Now, you actually know 3 methods for solving simultaneous equations for your GCSE exams, or you should know 3 methods. You've got solving by elimination, solving by substitution, and solving graphically. So no graphs here, so it's definitely not that one. So are we going to eliminate, or are we going to substitute here? Well, this one, when you've got 2 linear equations and they're all nicely lined up like this, the easiest way to solve them is by elimination. We're going to get rid of one of the variables by adding or subtracting the 2 equations from each other. Okay, so here I'm seeing that I've got plus 2y and plus 2y there. So these are already the same. So it's going to be super easy to eliminate y, because all I need to do then is subtract one equation from the other. And if I take 2y and I take 2y away from it, I'm going to end up with no y's left. Okay? So doing the same with the other parts of the equation. 7x take away 3x leaves me with 4x. We've already said that 2y take away 2y is nothing. And then 100 take away 48, that leaves me with 52. So what's x then? Dividing both sides by 4, I'm going to get x is 52 over 4, which is 4 to the 52 go 13 times. So x is 13. Okay, so that wasn't pretty easy. Not quite done yet though, because we need to find the value of y as well. We need to find both x and y. Now we eliminated y earlier, but we had these two with equation 1, equation 2, and that was equation 1. Subtract equation 2. So now I'm going to substitute the value that we found, x equals 13, into one of my equations. And it doesn't really matter which one you sub it into. Whichever one has the easiest numbers is normally what I go for. So times them by 3 is marginally easier than times them by 7. So I'm going to pick equation 2 then, and then say, well, 3x, 3 lots of 13, plus 2y is equal to 48. So 3 13s, what's that, 39? So 39 plus 2y is 48. So then taking 39 away from both sides, that's going to give me 2y is equal to 9. And then dividing through by 2, I'm going to get y is 4.5. So therefore, the solution, x is 13, y is 4.5. Okay? Now, it's a good idea at this point to double check. You know, you don't want to wait until August when your exams come back to see if you were right or wrong. You've made a silly mistake. Just as a quick check on these ones, it's a good idea to substitute back into equation 1 and then see how you did. Make sure it all works. Okay? So if you used equation 1, sub into equation 2 to check it. If you used equation 2, sub into equation 1 to get to check it. So 7x, 7 lots of 13, is that plus 2 lots of 4.5? Is that equal to 100? We're just going to double check. Well, 7 13s. What are 7 13s? 7 times 13, that comes to 91. So 91 plus 2 lots of 4.5 is 9. Is that equal to 100? Yes, it is. Kind of all good. Okay. Yeah. So we just, just a visual check. So better to know in the test rather than when you get your results back if you made a silly mistake. So yeah, double check. Question 12. AF, BC, DE, and DF are straight lines. BC and DE are parallel. That's marked already, isn't it? So BC and DE being parallel. It's marked here. Look. It's always good to read the text though, because sometimes these things aren't added on. P is 3 times bigger than R. P is 3 times bigger than R. Work out the size of angle P. Okay, so we want to work out P, but the only thing I really know at the moment is this 72 down here. So rather than like hyper focusing on the thing that we've got to find, that P over there, I just think, well, what have I been given and what can I find? And then just kind of mosey around the diagram until I've actually find what I want. Okay, so looking at that 72 there, I can see that, well, I know that this angle here is also 72 though, because these are vertically opposite. So that's also 72. And further, because these are parallel lines, then this angle over here is what we call a corresponding angle. So then that one is also 72 then, isn't it? So that's 72 too. Okay, now we've got an angle in the triangle containing P and R, and we know what the relationship between P and R is. So we know that P is 3 times bigger than R. So we could replace P with 3R then, couldn't we? If P is 3 times bigger than R, then P is equal to 3R. So rather than using P and R, I could just use 3R and R, and then I've just got one variable there. So I've got angles in the triangle that add up to 180. One of the angles is 72, one is R, and one is 3R. So I can say then that 3R plus R plus 72 must be equal to 180. Those three angles are adding up to 180. Okay, so collecting my like terms, that means 4R plus 72 is 180. And then taking 72 away from both sides, they're going to cancel, leaving me with 4R. And then 180 take away 72, that is 108. So that gives me a value of R by dividing both sides by 4. 108 divided by 4, 25 and 2, that's what, 27? So R is 27. Okay, now remember, R was not what we wanted to find. We wanted to find P. I found R, but I do know that P is equal to 3R. So I know that P is going to have to be 3 lots of 27 now then. So what's 3 lots of 27? 60 and 21, that's going to be 81, isn't it? So P is 81. Question 13. 100 people were asked about the distance they travel from home to work. The table shows information about the results. Yes, it does. So it's a grouped frequency table here, isn't it? It's grouped into different ranges, not actually all the same size. We've got 0 to 5, 5 to 10, which are all both width 5, and then we've got sort of a wider one, it goes from 10 to 20, and an even wider one from 20 to 40. Now part A says, write down the greatest possible number of people who work from home. Right, now if you work from home, how far away do you live from your house? You live 0 away from your house, don't you? Because you're actually in it. So presumably, if you work from home, you're going to be in the first category, which is 0 to 5. Unfortunately, this 0 to 5 category includes people who also live within 5 miles of their home, so not super helpful. But the greatest possible number of people who work from home, well, it could be 21, couldn't it? All of those people in the 0 to 5 category could actually be working from home and be 0 miles from home. Okay, so I mean, it could actually be none of them either as well, not conversely, but the greatest possible number is that there are 21. Part B says one person is chosen at random. Work out the probability that the person travels at least 10 miles. Okay, at least. At least means 10 miles or more. So which categories are 10 miles or more? It's going to be at least 10 miles. It's going to be this one and this one. Now the previous category, the 5 to 10, I mean that does have a 10 in it, but can you see that D is strictly less than 10? So it's not like the first question where D was greater than or equal to 0. D could be equal to 0 in the first question in the first group, but D cannot be equal to 10 for those 24 people in the second group because it has to be strictly less than 10. So we don't need to include those in this calculation. So altogether, there are 37 plus 18. What's that? 47, 55 people who live greater than 10, well, at least 10 miles away, 10 miles or more away. Okay, and altogether, how many people there are? I think there were 100, weren't there? Yeah, there are 100 people altogether. So then the probability that a person travels at least 10 miles is going to be the 55 people who live at least 10 miles away over the 100 people who took part in the survey. So the probability of at least 10, okay, is going to be 55 over 100. Okay, now the final part asks us to draw a histogram of the results. So we've got our graph paper and our axes already done. So what we don't have at the moment though is the frequency density. Notice I've got frequency density on the side here, but at the moment I've got frequency. Okay, so that's not going to do. What can you remember what the formula for frequency density? Frequency density was equal to frequency divided by class width for a histogram. So we take the frequencies and we divide it by the class widths, which is the distance between the upper and lower bound in each of these groups. Okay, so here the width of the first group 0 to 5 has a width of 5. 5 take away 0 is 5. The second one also has a width of 5. 10 take away 5 is 5. 20 take away 10 is 10, and 40 take away 20 is 20. So they're all the widths of my groups. So to find the frequency density, I'm going to divide the frequency by the class width to get the frequency density. So the first one is going to be 21 divided by 5. That comes out to be 4.2. The second one, 24 divided by 5. That comes out to be 4.8. Third one, 37. I can do that in one in my head. That's 3.7. And then 18 divided by 20. I can also do that in my head. That's 0.9. Right, okay, so they're my frequency densities. So now I need to draw the bars on my histogram to match them. Okay? Now, unlike a bar chart, histogram bars are touching, so they go from the lower bound to the upper bound to the height of their frequency density. So my first one is going to stretch from 0 up to 5 and be of a height of 4.2. So the first bar is going to look like that. And then my next bar is going from 5 to 10 at a height of 4.8. Now the next bar is a bit fatter. It goes from 10 to 20. And this time the height is 3.7. And then the last bar is even wider, isn't it? It goes from 20 all the way up to 40. So it's going to, and quite short, it's at 0.9 in height. So a bit of a dumpy little bar at the bottom there. Okay, so that's my completed histogram. So unlike, as I say, unlike bar charts, your bars will actually touch each other. Where one bar finishes, the next one begins. Yeah, and they can be different widths depending on the class width. Okay, should look like that. Question 14. A solid trophy consists of a stand and a player. There he is, look, standing on his little trophy top. The stand is made by removing a small pyramid from a large pyramid. That's what we actually call a frustum in maths. Nice name, that, frustum. Large pyramid is a square base, edge 8 centimeters, perpendicular height is 16 centimeters, and a small pyramid square base is 5 centimeters, perpendicular height 10 centimeters. We know that the volume of the pyramid is a third of the area of the base times its perpendicular height. Show that the volume of the stand is 258 centimeters cubed. Right, now to work out the volume, we need to work out the volume of the big pyramid, and then we need to remove this bit of the pyramid and then find out what's left. Okay, so I'm going to work out the volume of the big pyramid, and that's going to be 1/3 of the area of the base, which is a square, isn't it? So it's going to be L squared times the height of the pyramid. So it's going to be 1/3 L squared H, where L is the length of the edge of the base there. Okay, so that is going to be 1/3 of, what do they say it was? The big one is 8 centimeters, so it's going to be 8 squared, and I know the height is 16, so it's 1/3 of 8 squared times 16. Okay, so what's that? I might just leave it as a fraction for now because I know it's going to end up being one. So 8 squared is 64. 64 times 16. That's 1024 over 3. I'm just going to leave it as an exact form like that at the moment because I need to carry on and take it away in a sec, don't I? And then V small, the small pyramid. Again, it's going to be 1/3 times L squared times H, but that's L1 and H1, and that's L2 and H2. So what's that then? The second length is 5 and the second height is 10. Okay, so that's 1/3 of 5 squared times 10. And what's that then? So 5 squared is 25 times 10 is 250, so that's 250 over 3. Okay, so then the stand, volume of the stand, is going to be one take away the other. Then it's going to be the 1024 over 3 minus the 250 over 3, which leaves me with, well, it's going to be 774 over 3, isn't it? Which I'm hoping divides by 3. Does it? 4's, does 40, yeah, it might do it. Yeah, it might do. 774 divided by 3. That's 258, so that came out to be a nice old number in the end. Oh, it did actually give us the volume there, and I've doubled. So yeah, we got the right one, didn't we? So it is 258 cubic centimeters. Okay. Now in the second part of the question, it says the trophy is made from a metal of density 7.5 grams per cubic centimeter. The total mass of the trophy is 2,340 grams. Work out the volume of the player. Okay, so we've got the volume of the base, and we know that the mass and the density of the whole thing. So we can work out the volume of the whole thing and take away the volume of the base, and we'll be left with the volume of the little dude on the top. Okay, so that's what we're going to do. Right, so formula for density. Density, mass, volume, isn't it? Density, mass, volume. Okay, so what have we been given out of those three things? We know the density is 7.5 grams per cubic centimeter. And we know the mass is in 2340 grams. These are all compatible units, aren't they? I've got grams and centimeters cubed for my volume for the other one. So that's all good. And the volume is the thing I want to find then, isn't it? Okay, I want to find the volume. So put in my thumb on the thing I want to find. It's the V this time, so it's going to be the mass divided by the density. So volume is mass over density, which is going to be 2340 over 75 then. Oh, sorry, 7.5. Missed the point out there. And that's going to give me 2340 divided by 7.5. That's giving me 312. So that's the volume of the whole thing, isn't it? The guy on the base. Okay, and we already know that the base is 258. So the volume of the player is going to be the volume of the trophy minus the volume of the base. So the volume of the trophy we just calculated, it's 312, and the volume of the base we found earlier, it was 258. So then the volume of the player is going to be the 312 minus the 258 then, isn't it? What's that? 312 minus 258. That comes out to be 54 cubic centimeters. Question 15, we're given that A is the vector m3 and B is the column vector minus 4p. The diagram shows the vector 2a plus b. Work out the values of m and p. Okay. So what is the vector 2a plus b? We can see from the diagram that 2a plus b is the vector, well, what is it? I'm going along here and up here. So the distance in the direction of x is 9 subtract 1, that's 8 squares. And the distance up is 1 to 6, which is 5 squares. So writing that as a column vector would be 8 on the top and 5 on the bottom. Okay, so that's what 2a plus b is. But also 2a plus b is also 2 lots of m3 plus minus 4p. Okay, so then working that out, that's going to be 2m and 6, just multiplying that factor up like that, plus minus 4 and p. So that is equal to 2m minus 4 and 6 plus p. Okay, so comparing the two things, I know that that part there must be the same as that there, and this part here must be the same as that one there. So in other words, 2m minus 4 is going to be equal to 8. So solving that by adding 4 to both sides, that's going to give me 2m is equal to 12, or in other words, m is 6. So that's the value of m. And then doing the other one, 6 plus p is equal to 5. And then, so what's that? So p, well, that's a bit easy. P is minus 1. Okay, so then my two solutions, m is 6, p is minus 1. Question 16. PQ is the diameter of a circle. QR is the tangent to the circle. We know that QR equals we know that PQ equals QR. That's already marked on the diagram, isn't it? By the little marks here and here. That was already there. And we know that PR is equal to 10, which is not on the diagram, so I'm going to write it on. So this distance here is 10. Right, so what do we need to do? Work out the radius of the circle. Give your answer as a decimal. Well, I know that QP is the diameter, so the radius then is going to be half of QP then, isn't it? The distance from Q to P. So if you find the length of Q to P, then halve it will get the radius. Now, how are we going to do that? Well, I guess we could just use some basic trig, can we? Right, I think what we're going to do is, we know that QR is a tangent, so that means that it makes an angle of 90 degrees with the radius. So half of QP we said was a radius, so that's the radius coming out from the center to Q. So the angle between that and QR must be 90 degrees. So we've got a right angle triangle, okay, of which we know the hypotenuse. Now we don't know the two other sides of the triangle, but we do know they're the same. So I'm going to call them A and A. And that means we can then use Pythagoras theorem. Now normally Pythagoras theorem you'll need to know two things to find the third thing, but we know those two things are the same, so we kind of know two things. So usually c squared equals a squared plus b squared, isn't it? But in this case they're both the same, so it's going to be a squared plus a squared. So in other words, c squared equals 2 lots of a squared. Okay, so we know that c is 10, so then 10 squared is 2a squared, or in other words 100 is 2a squared. So then dividing both sides by 2, I'm going to get 50 is a squared, so then a is going to be the root of 50 then, isn't it? Okay, so if a is the root of 50, then the radius is going to be half that as well, isn't it? Because a is all the way across. So radius is half of a, which is going to be half of root 50. So this is a job for just tap it in the calculator now, isn't it? So I need to do half of the root of 50. What's that then? As a decimal, that is 3.5. Should you round it up? 3.54. 3.54, and I guess that's in centimeters. Okay. Yeah, so we needed to know a little bit of circle theorem rules. We needed to know that the radius and the tangent met at right angles, but mostly it was a Pythagoras question. Question 17. Here is a sketch of a quadratic graph, y equals f of x. The graph crosses the x-axis at a and b. Write an expression for the x-coordinate of the turning point. So you should know that parabolas are symmetrical. So I can draw a line of symmetry running down the middle of this graph like that. Okay, so that is a kind of a line of reflection in the parabola. So if that's the case, then the distance from here to there must be the same as the distance from there to there, mustn't it? There must be equidistant. So that line of symmetry is passing through the midpoint of A and B. Okay, so how can you find the midpoint of A and B? Well, you can find the midpoint of A and B if you take A and B and you add them together and you divide by 2. Okay, so A plus B over 2 is, that is the midpoint of the line, isn't it? Okay, so that's what you're going to get here. You're going to get A plus B over 2, halfway between the two of them. Okay, so that is my solution, A plus B over 2. Question 18, simplify. I've got an algebraic fraction here. I've got 2x plus 4 all to the power 5 on the top and x plus 4 to the power 3 on the bottom. Give your answer in the form ax squared plus bx plus c. Okay. Well, first off, let's think about our laws of indices here, because we've got two things with the same base, x plus 4 and x plus 4, raised to a power. That's raised to the power 5 and that's raised to the power 3. So dividing x plus 4 to the power 5 by x plus 4 to the power 3, then I'm going to subtract the indices. So 5 take away 3 is going to leave with 2, and then that's all going to disappear then, isn't it? So I'm going to get 2 lots of x plus 4 all squared. Okay. Then I need it in expanded form, don't I? I want to have it looking more like this. So either using your identity for perfect squares, which is a plus b all squared equals a squared plus 2ab plus b squared, which you can use to quickly multiply out brackets like this. So in other words, we take whatever's there appears at the front squared, so this is going to be x squared. Whatever's at the back appears as a square at the back, so I'm going to get like a plus the middle term plus 4 squared at the back, which is, I'm just going to work out in my head, is 16. Okay, and then in the middle I'm going to get 2 lots of the first term times the second term. So the first term is x and the second term is 4. So in the middle I'm going to get 2 times x times 4, which is 8x. Okay? So knowing this identity is just a quick way of multiplying out perfect squares like this. You know? Alternatively, you could just write x plus 4 and do what you normally do with quadratics, either foil or, you know, the grid, whatever it is. But I just find memorizing this identity and using it is quite handy for these sorts of expansions because they come up a lot. Okay, then finally I'm just going to multiply everything through by 2, so I'm going to get 2x squared plus 16x plus 32, and then that's my solution then, isn't it? 2x squared plus 16x plus 32. Question 19. AC is the diameter of a circle, centre E. E is the midpoint of BD. Prove that the triangle ABE is congruent to the triangle CDE. Okay, so we know that AC is the diameter of the circle, so let's just mark that on. And we know that E is the centre of the circle, so I can say then that that length there is the same as that one. Okay, and we also know that E is the midpoint of BD, so BD is this long line running down here. And then if E is the midpoint, then again, this line here is the same as this line there in length. So I'm just using these marks to show that they're the same length. Okay. Now, we've also got some angles that are the same. This angle here at E in the triangle ABE is going to be the same as this angle here, isn't it? Because they are vertically opposite. So those two are the same. Okay. So then, knowing that, I think we can easily show that these two triangles are congruent then. I think we've got enough information now. I just need to write that down in a way that's going to get me the marks. Okay, so what I need to show is for these two triangles being congruent, we need to use one of the rules for congruency. I either use ASA, SAS, SSS, or RHS. And I'm thinking what I'm looking at is an SAS proof, isn't it? Because if you look at the triangle ABE, this triangle up here, you can see that I know two sides and an angle are the same as the other one. Okay, so I'm going to be using SAS to prove that this triangle here is the same as this triangle over here. Okay, so these are my two triangles that I'm showing are congruent. Right, so we just need to write that down. We've got the proof already, it's just need to write it down. So what we're going to say, so to show that these two triangles are congruent, we need to prove SAS. Okay, so we need to show that two sides and the included angle are equal on both those triangles. So let's take the yellow one first. I can say AE is equal to CE, and I can show that BE is equal to DE, and I know that angle BEA is equal to angle DEC. Okay, they're the two pink ones, and I'm just going to put in brackets, they are vertically opposite. So therefore, I've showed that two sides and included angle are equal in triangle AEB and triangle CED. Therefore, triangles are congruent. And I'm just going to put in brackets SAS. So there we go. So yeah, I showed the yellow ones were equal. They're equal. The green ones are equal. The pink angles are equal. So we've got side angle side going on there, haven't we? Okay. Question 20. Solve 2x lots of x plus 10 is equal to 5x minus 18. Now this is a quadratic because I've got a 2x times x is going to give me an x squared term. So I need to multiply it out, bring everything to one side, make it equal to 0, and then see if I can solve it, hopefully by factorising. Okay, so first step, let's multiply out the brackets. I've got 2x times x and 2x times 10. That's going to give me 2x squared plus 20x. And of course, I already had the 5x minus 18 on the opposite side. So next thing is to move those over. Moving over the 5x, change sides, change signs, or take 5x away from both sides. You can think of it that way. I'm going to end up with 2x squared, which is already there. The 20x, take away the 5x, is 15x. And I've also got this minus 18 on this side. And again, when I take it over the equal side, it's going to change signs. So it's going to become plus 18. The other way of thinking about it, of course, is you add 18 to both sides. Okay? Yeah, different ways of thinking about the same thing. So that gives me 2x squared plus 15x plus 18 is equal to 0. Now, hopefully, I can factorise it because that will make my life a lot easier. So, can I factorise it? Well, I've got 2x squared at the front, and that means I'm going to have 2x and x in my brackets then, aren't I? 2x and x. Now, you'll notice that everything is positive, plus, plus. So that means everything is positive in my brackets, plus, plus. And at the end, I'm going to have two numbers whose can multiply together to give you that 18, don't they? So what are the factor pairs of 18? Possible candidates for those two numbers. It could be 1 and 18, could be 2 and 9, could be 3 and 6. Is that it? 4 is not a factor, 5 is not a factor. It's going to be one of those pairs. Okay? Now, which pair is it? It could be any one of those, but it needs to add up to 15 in the middle, doesn't it? Now, remember, whatever goes in the right-hand side gets multiplied by this 2x, so it kind of doubles its contribution to the middle term. And I want it adding up to 15. Okay, so I'm just scanning through those, thinking about how I can get 15 out of these numbers, and I think it's going to be this pair here. It's going to be this pair, isn't it? Okay, because if I put the 6 on the right hand side here, when it gets times by that 2x, it's going to give me, it's going to contribute 12x to the middle term, and the 3 here is going to give me the other 3, that's going to make 15 altogether in the middle. Okay, so it's going to be 2x plus 3, x plus 6 is equal to 0. Now, when you've got two things and they multiply together to give you 0, it must be that one of those things is 0, isn't it? It's the only way you can get 0 out of a multiplication, is if you multiply through by 0. Prove me wrong. I don't think you can. So that means that one of these two brackets must be equal if you're multiplying them together to give you 0. So that means that 2x plus 3 must be 0, or x plus 6 is equal to 0. Now if 2x plus 3 is 0, take the 3 the other side, I'm going to get 2x is minus 3, and then dividing through by x. I'll just show you that, 2x minus 3. And then dividing through by 2 is going to give me x is equal to minus 3 over 2. So that's one solution. The other one, x plus 6 is equal to 0. So just take 6 to the other side. I'm going to get x is minus 6. And that's my second solution. Okay, so two solutions. X equals minus 3 over 2 and x equals minus 6. Question 21. Water flows from a tap at a constant rate. A container is filled with water from the tap in 40 seconds. The graph shows the height h centimeters of the water after time t seconds. Part A says the container is one of these shapes. Circle the letter of the correct shape. Now you can see that the rate that the height is changing over time is changing with the gradient of this curve. So if I get my ruler out, you can probably see it a little bit clearer. So, you know, as we're going up this part of the curve, it's going quite fast to start with, and then the rate slows down as we go over that middle section, and then the rate kind of speeds up again as we go up to the top. Okay, so what does that mean in terms of the shape of the bottle? Well, if you think about it, if it's going quite fast at first, it means the same amount of water is filling the shape up in less time in this part, isn't it? Because it's filling up faster, and then it slows down. So in terms of the shape, it's definitely not going to be straight-sided, because that would have a constant fill rate. It would look like a straight line all the way up. It's not going to be the cone, or the frustum, I suppose, is a truncated cone, isn't it? Because that would continually curve in the same direction. So it's going to be out of B or D. Now, if it was B, that means it's wider at first. If you're filling this up from the bottom, if you think about it, at the bottom it starts being wide, and then it gets narrower as it goes up. So actually that's going to, if you were filling up with water, it would actually go faster up this part and then kind of slow down a bit there. So the graph of this one would look more like this. It would be slow, fast, slow. So I think it's going to be that kind of bulbous one at the end. So it's going to start off reasonably fast because it's quite narrow at the bottom. But the more water you put in, the wider it gets. So the more water it's going to take to fill it up. And then towards the top it starts tapering off again. So the speed of it increasing is going to go up again. So I think it's going to be D. Okay, it's like that shape. Okay. And then B, by drawing a tangent on the graph, estimate the rate at which the height is increasing when t is equal to 10. Okay, so t is 10 is down here, look. So just reading up to the graph there. So we're talking about this point on the curve, so that point there. Okay, so at that point there, what is the tangent going to look like? Well, I'm going to kind of just push the ruler against the curve, so it just touches the line at that point there, and I'm going to draw the tangent on. Okay, so it's going to be a straight line just touching the curve at that point. And if we want to know the gradient of the curve at that point, we can estimate it to be the same as the tangent at that point. Okay, so the tangent is a straight line, so we should be able to work out the gradient of the straight line. We just need to take 2 points on our graph and kind of triangulate it, don't we? So I'm going to see if I can take 2 nice points. So I'm going to take this point down here on the y-axis. So at that point there, look, just move the ruler out of the way, it keeps catching. So at that point there, what's that? That's 1, 2, 3, 4 little squares above 0. Now there are 10 squares between 0 and 5, so each one of those is going to be a half. So I reckon that's 2 at that point. And if we take one at 40 up here, look, that one is 1 little square below 15. So that's going to be 14.5 at that point then, isn't it? So then my tangent, if I look at change in y, so gradient m, is going to be change in y, which is, let's just draw the triangle on, I'm going to use. Now you can use any 2 points actually. I tend to use as wide a gap as possible so it's the most accurate. So the distance, the change in y is the height of this line here, isn't it? So it's 14.5 down to 2. So that's got a height of 12.5. So the change in y is 12.5. So that's going to go on the top of my gradient. And then the change in x is this distance along the bottom. So it's 0 up to 40. So it's going to have a length of 40 then, isn't it? So that's going to divide by 40. So then tappity-tap that into the calculator. So 12.5 divided by 40. That's giving me an answer of... That gives me the answer of 5/16 or 0.3125. I'm just going to write down 5/16, I think. 5/16. So what is... Oh, the unit I've already been given. It's centimetres per second. That's right. That matches what I've got. So that's 5/16. Now drawing tangents is a little bit variation allowed. So you might have done yours slightly steeper or slightly shallower. As long as yours is more or less where mine is, that's fine. It doesn't have to be exactly the same. Question 22. Write 7 over 2a squared minus 3 over 5a as a single fraction in its simplest form. Okay. Now, there's nothing particularly special about algebraic fractions. They work the same way as normal fractions. So imagine we had 5, 6, and we were subtracting, I don't know, 2 ninths from it. Okay. Then the first thing we would need to do is find a common denominator of those two numbers, isn't it? So what's the common denominator of 6 and 9? Well, you always get a common one by multiplying the two numbers together. 6 times 9 is 54. But often there's a smaller one because 6, if you think about it, is actually 2 times 3. And 9 is 3 times 3. So if you were finding the lowest common multiple of those two numbers of 2 times 3 and 3 squared, you would take each power that appeared to the lowest power it appeared. So it would be 2 times 3 squared, wouldn't it? So there is a common denominator of 6 and 9, which is smaller than 54. It's going to be 18. So actually you could have a lowest common multiple of those of 18. So it's not always the two numbers multiplied together that gives you the lowest common multiple, because sometimes they share factors. Now the reason I'm saying that is because these two share a factor. They share a factor of a. Okay, so and just like these 6 and 9 share a factor of 3, and therefore your lowest common multiple is 3 times less than two things multiplied together, the same is true over here. We don't need to include all of the a's on both sides in our common denominator. We can just take the 2 and 5 are different, so we're going to have to include both of those. So 2 times 5 is 10. But we've got an a squared and an a. We don't have to include both the a squared and the a. We can just take the a squared as a common denominator of both. Because 2a squared goes into 10a squared and 5a goes into 10a squared. 2a squared goes into 10a squared 5 times. 5a goes into 10a squared 2a times. Okay, so it does go in, so we don't need to put 2a cubed on the bottom there. Okay, right, so then on the top, now if we were doing the real numbers over here, we would take the 5 and we'd multiply it by how many times 6 goes into 18, which would be 3 times, and we would be subtracting 2 times how many times 9 goes into 18, which is 2 times. And we're going to do the same thing here. We're going to take the 7 on the top, and we're going to multiply it by how many times 2a goes into 10a squared. So it's going to be 7 times 5, because 2a squared goes into 10a squared 5 times. And then I'm going to subtract the 3 there, multiplied by however many times 5a goes into 10a squared. Now 5a goes into 10a squared 2a times, so I'm going to multiply that by 2a. Okay? So you take the values in the numerator and you multiply it by how many times the original denominator goes into your common denominator. That's how it kind of works. Okay. So then once that's all done, then I can just matter of multiplying it out and tidying it up now. So 7 times 5 is 35 minus 3 times 2a is 6a over 10a squared. Now can I make that any more simple than it already is? I don't think so. I think that's about as simple as it's going to get. 35 minus 6a over 10a squared. So yeah, if you're struggling with algebraic fractions, just think about what would I do if it was numbers, and do the same thing. Algebra is just generalized arithmetic, so what the rules of normal arithmetic apply to algebraic arithmetic, just the same. So think, what would I do with numbers, and do the same thing with your letters. Question 23. A chocolate box in the shape of a prism is being designed. All lengths are in centimeters. The cross section is a regular hexagon with side x. The length is 5x. The expression for the area of the cross section in squared centimeters is 3 lots of root 3 over 2 lots of x squared. The total surface area of the box must be less than 650 centimeters squared. Work out the largest possible integer value of x. You must show your working. Oh, this is interesting. So I think that probably the easiest thing to do first is to come up with an algebraic expression for the total surface area of this shape. Okay, so what is the total surface area of this shape? Now, how many sides does this shape have? Well, it's got your two ends. So you've got this end and you've got this end over here, and they're identical, aren't they? And we know what they are. We were given it here. So that is the area of the two ends. So we got two of those. So I'm just going to double that up. So 2 lots of 3 root 3 over 2 lots of x squared. So they're the two ends. Now, as well as that, we've got a number of sides, rectangular sides, haven't we? So we've got this one here is one example. That one is x times 5x. So this is all 5x times x, which is 5x squared. And we've got, actually, because it's a regular hexagon, it's going to mean that all of those 6 faces along the sides are going to be the same. So we're going to have 6 of those. So I'm going to add on the 6 rectangular faces of the prism, and each one of those is 5x squared. Okay? So we just need to tidy this up now. Actually, it wasn't too bad, was it? So that 2 and that 2 cancel, and that leaves me with 3 root 3 x squared, and then 6 times 5x squared is 30x squared. Okay, so factorizing out the x squared, that means I've got 3 root 3 plus 30 lots of x squared. Okay, so just put in that part and that part together in a bracket and factorizing out that part. Okay, so that part appears on the end, and then those two parts appear in the bracket like that. Okay, right, so what do we need to do with this? We need to work out the largest possible integer value of x such that the total surface of the box is less than 650. So I feel like we've got an inequality coming on here. So what we're going to do is we're going to take that expression, 3 root 3 plus 30 lots of x squared. That needs to be less than 650. So then rearranging that to make x the subject, I guess x squared then is going to be less than 650 divided by 3 root 3 plus 30 on the bottom like that. Okay. So then I suppose x is going to have to be less than the root then of that 650 over 3 root 3 plus 30. Okay, so then I just suppose I just need to then type that into my calculator and then round it down. So what is the root of, I'm going to use the fraction key so I can just type all of that in one go. So 650 on the top, and on the bottom of my fraction, 3 root 3 come out of the root plus 30. What's that then? Okay, I make that 4.297. So I'm just going to round off to 4.3. So x needs to be less than 4.3. So given that I want the largest possible integer value of x, that's the whole number value, the largest whole number which is less than 4.3, it's going to have to be x is 4 then, isn't it? So that's my solution. X is going to be equal to 4. Question 24, work out the area of triangle ABC. Okay, what have we got here? We've got a non-right angle triangle where we know 2 angles and 1 side. Okay, now working out the area of a triangle, either we need to know base times height, so we can use half base times height, or we could use the trigonometric version of finding an area of a triangle. Area of a triangle is half AB sine C. That's the formula. Now the thing is about that area of a triangle formula though, you need to know 2 sides, so you need to know like A and B, and you need to know the angle between them, C. Okay, that's what you need to know in order to use that formula. But here we don't have that, do we? We've got 2 angles and 1 side, and that side's not included. So but before we can use this formula for working out the area, we need to know another side, and ideally we want to know BC. We want to know this side here. So then we've got 2 sides and the angle between them. I could use the sine rule because I've got lots of angles and a side here, and the sine rule uses opposite pairs. So I've got that one there which is opposite that one there, so that could be one pair that I use for the sine rule. But given that I want the other side over there, I'm going to find this angle first. 180, take away the other 2 then, isn't it? So 180 minus 73 plus 56. So 73 and 56, that makes 129. Take that away from 180. That's going to be equal to 51 degrees. Okay, so that one's 51. Okay, so then we want the angle which is 51 and the side opposite we can then find, isn't it? So we can then find that side using the sine rule. So we're going to use the sine rule. Using sine rule. It's a good idea just to say what you're doing with when you're doing maths. So using the sine rule. Now there are 2 ways you can write the sine rule down. You can either write it with the angles on the top, or you can write it with the sides on the top. And I usually write it down with whichever way has the thing that I want to find on the top. So I've got less rearranging to do. So I want to find side A, don't I? A is the side opposite angle A, and I've got C, which is opposite side C. Okay, so I'm going to say A over sine A, because A is the thing I want to find. That is equal to C over sine C, because they're the things I've got. Okay, so subbing in what I know. So A over the sine of the thing of angle A is 51 is equal to C, which is 24, divided by sine of 73. Rearrange it to make A the subject. A is going to be 24 sine 51 over sine 73. Then just moving or cross multiplying that up there. Look, that's moving up there, leaving me A by itself. So time to tappity tap that into your calculator then. 24 sine 51. Good idea to close brackets when it's a bit more complicated like this. Divided by sine 73. That comes out to be 19.5 to me. Now that's rounded off, so I just recommend that you keep that on your calculator so that when we sub it into the next one, we use the actual value rather than the rounded one. So don't clear it off, just leave it in your calculator. Right, and then moving over to the area formula. Now we've got 2 sides and an included angle because we know A is equal to 19.5 now. So now we've got this side and we've got this side. We know both of those and we know the included angle, and that's what we're going to use here then. We know the included angle is 56 and we know the 2 other sides, either side of it, so we know those. So subbing those in, so a half times 24 times the 19.5 I just found times the sine of 56. Okay, so tapping that into the calculator, so I'm going to type in 0.5 times 24 times answer, because I want the full accuracy of my last answer, and then times the sine of 56, close bracket. What's that then? That comes to 194. 194 what? Question 25. A is 3/4 of C, and we know that 6b is equal to 5c. Work out the ratio of A to B to C. Give your answer in its simplest form where A, B and C are all integers. So A is 3/4 of C. So how am I going to write that down as a formula? A is 3/4 of C. So if A is equal to 3/4 of C, let's say we let C equal 4, then A would be what? A would be 3/4 of 4. So 4 divided by 4 would be 1, and then 1 times 3 is 3. And that would mean that A is equal to 3 then, isn't it? Now we don't know what C is, but we do know that if C was 4, then A would be 3. And that's enough to give me the ratio then of A and C. So if I write this down as a ratio, then I know that when A is 3, then B is going to be 4. Okay, we don't know what B is yet. We don't know. We've only got those two things at the moment. Right, and then for the second one, when 6b is equal to 5c, then, isn't it? So I could do a similar thing here. I could say then, well, b is 5c over 6. So if I let c be equal to 6, then what would b be? So 6 divided by 6 is 1, 1 times 5 is 5. That would give me b was equal to 5, wouldn't it? So if c is equal to 6, then b is equal to 5. So I can write that down as a ratio as well then. B and c are in a ratio of 5 to 6 then. So I could put a 5 here and a 6 here. Okay? Now this part we don't kind of know those two there. But what we want to try and do is we want to try and piece these two ratios together. So we've got one big ratio that's got all three numbers in it. Okay, now you'll notice we've got values for C of both of them. So what we can do is we can just find a common multiple of 4 and 6. What numbers do 4 and 6 both go into? They both go into 12. So if we can just scale up these ratios so that they are, they've got a 12 for both of them on the end, then we can piece them both together then. So if you think about the first ratio, 3 to 4, if I scaled that up by a factor of 3, so I times that by 3, then 4 times 3 is 12, and then on the other side, look, times 3, I'm going to get 3 times 3, which is 9. So that means that A and C are in the ratio of 9 to 12, doesn't it? But I can also do it with the second ratio. If I take the second ratio and I times it up by 2 and do the same this side, times 2, then my ratio of B to C of being 5 to 6 is the same thing as the ratio of 10 to 12. So that means I can fit a 10 in there then. And that means that A, B and C must be in the ratio of 9 to 10 to 12. Now, can I cancel that down at all? Nope. They haven't got any common factors, have they? Because of the 10. Okay, so yeah, that's it. 9 to 10 to 12. If I've done everything, work out the ratio of A to B to C. Give your answer in the simplest form where A and B and C are all integers. Seem to have done it. That's good. Move on. Question 26. In a game, these numbered tiles are in a bag. Got 4 5s, 2 3s, a 2 and a 1. So how do we play this game then? Choose a tile at random, one at a time, and do not replace the tiles. You win if at any stage the total of the numbers on your tiles is 10. Amber plays the game once. Work out the probability that she wins. Okay, now how can I get a 10? Okay. Well, I suppose I could, if I picked a 5 first and then another 5, that's a win, isn't it? Ways to win. I could get a 5 and then a 5. That would be one way of winning. Are there any other ways of winning? Well, I guess I could get a 5 and then a 3 and a 2. That would also be a win. And I guess any other combination of those three numbers as well, wouldn't it? So if I pick a 3, a 2 and a 5, that's also a win. Or if I pick a 2, a 3, a 5, that's also a win. Is there any other ways of writing that down? I could have a 5, a 2 and a 3, that's also a win. I could have a 3, a 5 and a 2, or I could have a 2, a 5 and a 3. So actually there are 6 ways of getting those 3 scores, and isn't it? 6 different ways of getting winning with a 5 and a 3 and a 2. Now, is there any other way of winning? No. If you pick a 1, you can't win, can you? You can't get 10. You're just gonna go past it. So if I pick at 1 at any point, then picking the 5s would make me jump past 10. Missing it, I'd go to 11 or something. So I don't think there's another way of doing it. So I think they're the only ways. So if I want to work out the probability that she wins, I need to work out the probability of those different outcomes. Okay. So what is the probability of picking a 5 and then a 5? Okay, so what's the probability of 5 and then 5? Well, that is going to be, well, there are 1, 2, 3, 4 5s in the bag out of a total of 8. So the chance of picking out a 5 on the first selection is going to be 4 out of 8. Okay. Now let's assume she picks a 5 first go round. Now what's the probability on a second selection? She's going to pick that second 5. Well, you'll see she's only got 3 5s left to pick from, and there are only 7 cards left to pick from, because we don't replace. We do not replace, do we? Do not replace the tiles. So there's definitely 1 less tile in the bag, and there's 1 less 5 in the bag. So for the second selection, it's going to be 3 chances in 7 of picking that one. Okay. Now, if I was working out the probability of a 5, a 3, and a 2, I'm just going to get rid of this 6 ways here. We'll come back to it in a minute. So then what's the probability of getting a 5 first time round? So again, it's going to be 4 chances in 8. And then we're going to multiply our chances of getting a 3, which is 2 chances in 7. And we're going to multiply that by the chance of getting a 2, which is 1 chance in 6. Okay, so 5, 3, 2 would be 4 to the 8, 4 8s times 2 7s times 1 6. Now, do I need to work out all the various probabilities of everything after that point? Well, not really, because if you think about it, what's the probability of getting a 3, a 2, and a 5? Now, the fractions I'm going to write down are different. Probability of getting a 3 on the first selection, so there are 2 of them out of 8. Probability of getting a 2 on the second selection, there's 1, 2 out of 7. And the probability of picking a 5 on the third selection, it's going to be the 4 5s over the 6 remaining tiles. Okay, now these are different probabilities I've written down, but you'll notice on the bottom, they're all 8 times 7 times 6, 8 times 7 times 6. And on the top, we've got the same numbers, 1, 2, 4, 1, 2, 4. So all of these different selections, all these different 6 selections will have different fractions, but overall they're going to give you the same answer, because every time you're picking the 5, there are 4 to pick from. Every time you're picking the 3, there are 2 to pick from. And every time you're picking the 2, there's 1 to select. And every time you pick the first one, it's going to be 8. Every time you pick the second one, it's 7, 8. Every time you pick the third one, it's going to be 6. Okay? So all of these are just going to be variants of the same answer. So if I can just work out 1 and times it up by 6, I've got all of them. So I don't need to do all of that malarkey down here. So all of this down here, I can just do by taking one of them and timesing it up by 6. I don't have to keep doing it over and over and over again. Right, so the probability that she wins then, probability of win, that's going to be the probability of 5, 5 plus 6 lots of the probability of 5, 3, 2. Okay, so the probability of 5, 5 we just said was 4 8s times 3 7s, and then we've got 6 lots of 4 8s times 2 7s times 1 6. Just taking my top answer from over there. Okay, so that's the probability. Now we just need to work out what that is. So I'm just going to just type it all into the calculator. As long as you're careful, you should be able to do this without too much problem. So 4 8s times 3 7s plus 6 times 4/8 times 2/7 times 1/6. What does that come out to be? Apparently that's 5/14. 5/14. Okay? Yeah, so that's my answer, 5/14. Question 27a. The graph of y equals x cubed is translated to the graph of y equals x minus 2 all cubed. Write down the translation vector. Okay. Now you need to know the 6 types of transformations that they can test you on in this exam. You need to know the translations, the reflections and the stretches and how they work and what the algebra part of it is going to look like. Now here we are going from an x, which is then cubed, to an x minus 2, which is all cubed. In other words, we are subtracting 2 from the value of x inside the function. Okay, so that is a translation. It's going to be a translation, and it's going to be a translation of 2 units in the direction of x. Two units in the direction of x, okay, going up the scale, so off to the right. Okay, so we need to go 2 units to the right. So as a translation vector, if you imagine a graph and we've got our curve and we're taking each point and we're moving it 2 to the right, that is a translation vector of going 2 in the direction of x and 0 in the direction of y. So that is 2, 0, like that, to move your graph that way. Okay. It's just a rule of thumb, like, you know, when you doing it in the direction of x, it's always kind of the opposite direction to the signs, and when you're doing it in a y, it's the same direction as the signs. You get kind of used to these after a while. And then B, the graph of y equals 5x plus 4 is reflected in the y-axis. Write down the equation of the reflected graph. Okay, so we want to reflect in the y-axis. So reflecting in the y-axis, f of x goes to f of minus x, which means we have to replace x in our function with negative x. So our new graph is going to be y is equal to 5 lots of minus x plus 4. In other words, I'm going to get y equals minus 5x plus 4. Okay, that kind of makes sense, doesn't it? You imagine your graph. The graph of y equals 5x plus 4 is quite a steep graph going through 4 like that. It's going to be like that. And then if you do minus 5x plus 4, it's going to have the same y-intercept. It's going to be as steep, but in the opposite direction. It's going to be sloping downwards rather than up. And you can see that does kind of make the reflection in the y-axis, doesn't it? Okay? Yeah, so y equals minus 5x plus 4. But there's no ways around it. You know, this big table, you need to learn it. This is stuff you need to know. You know your facts, then you'll do all right in the exam with your translations.
Mr. T, he's the